Okay, so picking up right where we left off, let's go to the hero walk script. And these are the four sections we just added, these four if statements. And basically we check to see if the walk up key is being pressed, the walk down key is being pressed. The problem with this is that when a key is pressed, it adds velocity. And just like real physics, an object in motion stays in motion. So we need to add one additional check that removes the velocity and brings the object to a stop. Now, what makes that a little bit challenging is that whereas this, you're checking for a condition, you have to check for the lack of a condition. You have to check for this not happening. So where this is a check of something happening, you have to check for something not happening. And the way you do that is you use an exclamation point. An exclamation point is, for whatever reason, C# way of saying that something is not happening. And you usually, it appears as a prefix. And I'll show you that in just a second. So because of how complex the line is that we have to put it in, I'm just going to paste it in because it has a lot of parentheses. You're probably going to want to pause the video to make sure you get it down right. But the good news, it's not as bad as it looks. It's basically each one of these conditions put into a single line. And what it's going to say is if this is not happening, and this is not happening, and this is not happening, and this is not happening, then come to a standstill. And when you think about it, it makes sense because you don't want the motion to stop just because one button isn't pressed. You want the motion to stop if no buttons are being pressed. And this is what it's going to look like. So here's the exclamation point that I talked about. Again, looks strange. It's not how you normally see an exclamation point in normal sentences, but in code, this is how you say something is not true. And it's just used as a prefix. So you're saying if this is not true, so if walk up is not true, and if this is not true, walk down, and if walk left is not true, and walk right is not true, then this should look really familiar, and now it's just 3 zeros, excuse me. It's just 3 zeros, X, Y, and Z. There is no velocity in any direction. So that's probably the most complex line that we've seen, but as I said, it's really the same concept repeated 4 times. It's just the parentheses can be a little bit challenging. So you've got the opening parentheses, a second one for the component, and because it's an input, you also have another set of parentheses. So it's 2 open, 1 open, 2 close, 1 open, 1 open, 2 close, 1 open, 1 open, 2 close, 1 open, 1 open, and 3 close. So now we just save this. And like I said, you might want to pause the video, that way you can get that down. I zoomed in a little bit more so it's a little bit easier to see. So now what happens is when you let go, it stops. Press down, when I let go, it stops. Press over, let go, it stops. Press over, let go, it stops. And so if we had tested a little bit more in the previous video, you'd have seen that when you let go of the button, it would have kept moving. And while we're at it, we might as well put in just a little bit more code which gets her facing in the right direction when she's walking. That way you don't have to redraw. In this case, it's only one image, but if she had a walk cycle, you don't have to redraw the whole walk cycle. So we go back to our script. We're going to use getComponent. This time it's the transform component, Euler angles attribute. And since the character is drawn facing up to begin with, then when they're walking up, we don't want any rotation. If they're walking down, then we need 180. If they are walking left, I believe it's -90. And if they're walking right, it's positive. You might have to switch those, we'll know really quickly. It's an easy tweak. Save that. So up, down, left, right. Yep, I always get those wrong. So and depending on the default direction your character is facing when you draw them, these could be entirely different. I just happen to have her facing up in the default appearance. And let's go back now. Up, down, left, right, and when you let go in any direction, they stop. So it doesn't have a walk cycle, but again, this is just really getting the foundation to be able to launch into the combat and then have somewhere to come out of the combat. Because if this was a legitimate overworld, when you get to the borders, it would scroll or would load another area like the old 8-bit adventures where you'd have an area, you move up, and then the next map appears. So now that we've got that all in place, now we can get to the reason why we're making this particular video, and that is to be able to actually load the battle scene. Now we're going to have to go to a menu that we haven't gone to before. We're going to go up to File, and we're going to go to Build Settings. Basically, this determines which scenes will actually be in your final game. You may have test scenes that you don't want, maybe it's a demo so you don't want all the scenes in there. For whatever reason, there's certain scenes that you may not want. So what we do is when you're in a scene, you choose Add Current, and then we'll just close out of that. We'll save our scene. Go to Battle, just by double clicking on it. Go back to Build Settings, Add Current. Now both are in there. Close that. Now we can go back to Overworld, and on our hero walk, we're going to add a randomize, just like we did for selecting which enemy appears. In this case, it's going to be whether or not an enemy is attacking. We'll just call it Encounter. Now what we'll do, you can either have it be based on update, so every frame, once per frame, it can check, or you wait for a key press. So let's do it, let's base it on frame, so that means it needs a large selection, or else we'll get too many encounters. So encounter equals random dot range if encounter, remember it's the double equal sign inside of the if statement. Actually, let's make it less than or equal to, let's say 20. So if that happens, then application dot load level is battle. So we'll save that. And now, since that's happening, it's checking that statement every single frame. Even if we're not moving, it should check. Okay, so that was kind of quick. You can see it wasn't quite as quick that time. Okay. So let's make that 1500. See much more of a delay that time. So that's it as a timer. Well, not really as a timer, because it's slower systems would have a slower frame rate, so, but it's more of a still a real-time check as opposed to based on a keystroke. So what we do is, let's leave this here. That's what we'll do. So we'll leave the calculation there, but we'll only check inside here. And we're just copying and pasting. A little bit messy, might be a slightly cleaner way of doing it, but again, I think this, even though it's a little bit more wordy, you get the idea that that it's the same command over and over again. 120? So, yeah, so it's like a 1 out of 6 chance. So, the way this works, key down, it's only the frame in which you actually press it down. So even though you're holding it down, it's only actually checking once, but you keep moving because it's velocity, because you've given it momentum. So it's only actually checking and coming true once when you press the key down. So this is basically a 1 out of 6 chance. It's not perfect, because if someone's moving in just one direction and they don't keep changing what button they're pressing, then they could actually go a while without combat, and players could pick up on that exploit. So those are two different ways to do it. One effectively works like a timer because it constantly checks whether or not you're doing anything, and the other is it's only checking when you actually press a key. So that should about do it as far as moving her and checking for combat. And the next video will be how to exit combat. So that means we're going to add a few things like setting HP to 0 and things like that.